attach the diagram here only. First, let me explain this part. Better to draw a diagram. Give me time. I'll draw it. I'll finish off in a less. This is a container. A really very beautiful question. The overall surface tension idea. One more reference line is coming. H/4. This is the H, so the liquid here will rise to height H. Okay, one diagram is sufficient. I think with this I'll manage. Okay, this is the, it will rise to height H. What is H? Angle of contact. A good concept is in what? Please do make no integration, nothing. The just only thing is we should make the height of the force due to surface tension will balance the weight of the liquid. That concept is what I'm trying to reflect here. Siphon, I think this problem is based on siphon. There, when we are discussing siphon, we didn't bother surface tension because at that time we didn't have idea. Now, the siphon works on based on surface tension. Let me show the liquid. Yeah. Okay, first time I'm coming to the between first and second diagram. Let's compare and try to figure out the options. Till here, no problem. Okay, let's continue with the question. So this is the first diagram. Second diagram. Okay, let's see that. It's telling radius of curvature of the meniscus. So what is that height? He has given h/4. So let me write that h/4. So this is the h/4. So how the meniscus will be? I'll say that the meniscus will take shape. Are you seeing curvature there? Appearing flat. You have to look at this curvature. That is the concept. That is what he's asking. Radius of curvature of meniscus at the open end of capillary tube. Open end is, this is what open end. This was the open end. Okay, let's what to do with this particular problem here. So radius of curvature is asking. So here I'll choose 0.1. I'll magnify it. Everyone is able to see things clearly. Okay, this is the 0.1, 0.2. Exactly bring .2. So exactly bring this one here. This is 3. This is 4. This is 5. What is the pressure at 145? Able to see that? Pressure at 145. Should be equal to P naught. Pressure at 145. So pressure at 145 should be P naught. What should be the pressure at 3? So here we are going to write equation P3 plus rho g h by 4 minus P4 equal to 0. So what is the pressure at 3? One more step. I think P3 plus rho g h by 4 minus P naught equal to 0. Let me have this one. This will be, so what is P3 equal to? P3 is equal to P naught minus rho g h by 4. Fine. Okay, let's come for pressure at 1, 2. Let's write equation at open end. P1 should be equal to P2 plus surface tension 2T by R. R is the radius of meniscus there. Let me write R. Now what is the pressure at 1? P naught. What is pressure at 3 and 2? The liquid is at rest, no? What is the state of liquid at rest? So pressure at 2 and 3 should be equal. So I'm going to equate these two here. Able to understand? No? So it's really, we have to put effort here, not possible. By saying we can't answer. That's what students nowadays, they don't want to think, that's all. In a nutshell, nobody wants to put some pressure on the brain. Everyone wants to happily, how we enjoy movie, like that, they want to enjoy science. How it is possible? P3 equal to P naught minus. So therefore, what is the radius of curvature? 8T by rho GH. Correct statement. If you want, I'll make it correct. Then A is correct. So this would be the radius of curvature. This is correct, I'll write it. Now similarly, what is telling? He has, look at the meniscus, how it is, how the meniscus concave towards air. Meniscus is concave towards air. Now in the second diagram, third diagram, first and third diagram will compare. So what he has brought a liquid at a height below the reference level, at a h by 4. Shall I complete it? All of you able to work out? See that this, we have to fight with the diagram. There's no other way. Even as a teacher, I should draw diagram, think, analyze, as some I'm able to do. Otherwise, gone. Now let's come for okay. You see this? I'll make an adjustment here. So the pipe, what happened? I should draw it down. No, let me have. I'll erase this. This not needed. No. Okay, somehow I'm adjusting it. Okay, now where do it is? It has come to h by 4. Below this one. Let's have a reference here. Let me fill up with a liquid. I'll show the meniscus will be like this. I have to ask questions. Sir, why the meniscus? Liquid will flow out from the pipe in the above diagram. Not possible. I think I'll read question now. So what is h by 4? No. So h by 4 is what I should bring it here. So shall I only show this? There's a third situation. Yeah, see things clearly. H by 4. The opening is at h by 4, 4, 5. So again, we'll proceed similar way. 1, 2. Let this be 3. Can you say anything about pressure at 145 is equal to P naught? The same story again. What is the state of liquid? Is that at now where the pressure at 3 and 4 should be equal? No, pressure at 3 almost we say what should be the pressure at 3 also? Should be equal to P naught. Pressure at 1, 4, 5 and 3 should be equal to P naught. Now there's a third diagram. Shall we write some equations? First we'll write some equations. Let's see what we can get help. Pressure at 145. So pressure at 2 should be equal to P1 plus 2T by radius of curvature. Some R may not be equal to that one. So some R it is. Pressure at 1 is P naught. P naught plus 2T by R. Let's write a manometric equation. P3 plus rho G H by 4 minus P2 equals 0. What is P3? P naught. Rho G H by 4. What is P2? P naught plus 2T by R. So what is R is equal to? Again, R is equal to how much? Water should flow? No, water will not flow. The reason for that, the force due to surface tension is able to balance the weight of this particular liquid column. Getting the idea? You have to really come for the picture. Here, will it be flat? No, it will be curved. Who will balance this weight of liquid column? Who will balance this weight of liquid column? The force due to surface tension. Agree this? So how much it can balance? It can balance up to height h. No, similarly, same thing here. Able to understand now? H by 4. Yes, the water will not flow, will not rush. But in siphon, what we made, just if this length is, if the mouth of the pipe lies below this atmosphere, the water will rest, practically will not rest. Getting the idea? Water will not flow. I think I should write this comment. Water will not flow out here. Fine. This one. Okay, this I think no. Radius of curvature of meniscus at the open end of the capillary in figure 4 is. Look at now. So finally, this is the edge. Huh? This is the edge. No? In figure 4, let's come for this one. In figure 4, radius of curvature of meniscus at open end of capillary in figure 4 is. So what is the figure 4? He will bring this pipe length below this one. So what is the maximum height? What is the force due to surface? What length of water column it can balance equal to capital H? No. What about here? No. I'll keep on increase. I'll increase the length of this pipe. So what is the maximum length it can balance? Equal to H. No. If it is greater than H, look at the last part. I think I need one more page. All of you, if you say that, sir, we understood, I'll be very happy. Yeah? Because through diagrams I'm explaining. Actually, I should not draw a diagram. So none of you will understand. So that's why I had to show with the help of diagrams here. Okay, let's take the last condition. The last part. Let me write this one. Now let's get into okay, now let me extend this pipe below this one. What is the extension he has made? So it has brought look at this. So this is the H. So how much it is? H by 4. How the meniscus? Anybody? What will happen to water? So can it really hold that particular? Now you should really answer this question. Water will flow, or can it still force due to sufficient can balance the weight? So here is the concept. Look at this one here. Who will balance this weight of the liquid column? This force due to surface tension. How much of length of liquid column it can balance? Rho H length. The force due to surface tension. Similarly, same thing here also. If it were till the pipe were till here S, it would have balanced. But here how much it is? H plus H by 4. So 5H by 4 length it cannot balance. So what will happen? The liquid will flow out here. Not possible. So the liquid what happen? In fact will rush. Now what is the velocity? 2g h plus h by 4. So no question of meniscus, no, the liquid will come out. Okay, this is the fourth diagram. Third, I think. Third, okay, fourth. Okay, fine. This will be what happened. Radius of curvature meniscus open curve. Not this is correct. This is correct. This is incorrect. Please do think. It's a very good problem. Okay. Similarly, one more is there. I'll leave it to student. Please do work out. Same idea. Who will balance the weight of? Okay. Let me just. Some information is there in the. So this is the. Agree this. The liquid. There's a liquid. Okay, please do think. So who will balance the force due to sufficiency can balance this much of H. Now is bringing H. I think just now we discussed, no? If H greater than capital H, so what should happen to level of? I think the water will flow, correct? This one. Can you, and the water does not flow out and meniscus is convex if H is less than H. I think justified, no? So here it will be the shape. Just now we had discussed here. Now again, water does not float and the meniscus, if capital H is equal to 0, if it comes here, how the meniscus will be flat. Okay, do think on this one. I'll similar one more problem. Let me work on. This is very important idea. Okay, no. Same concept. Question is brought once again. I'm bringing.